All right, this is lesson 11.1, writing equations to represent situations. This is page 297. The essential question reads, how do you write equations and determine whether a number is a solution of an equation? And I'm going to go ahead and scroll up a little bit. We're going to do some reading here. Determining whether values are solutions. Please read along with me. An equation is a mathematical statement that two expressions are equal. An equation may or may not contain variables. For an equation that has a variable, a solution of the equation is a value of the variable that makes the equation true. So, what do we've got here? An expression represents a single value. So this would be a numerical expression because it's numbers. This would be a word expression because there's numbers. And this is an algebraic expression because it's got a variable in it. And an equation, conversely, has to have an equal sign, basically. Basically, it can be the same thing. These are all the same thing. All the things I highlighted on the right are the same as on the left. But on the left, they don't have equal signs. So if you have equal signs, equal sign, the word is an equal sign, equal sign. That makes an equation. Equa is kind of like an equal sign. And an expression is the same thing, but it lacks an equal sign. Let's check out the examples. Example 1 says, determine whether the given value is a solution of the equation. So they give us this right here. They give us x plus 9 equals 15. And if I told you to solve right now, you might be confused about what to do. Except for right after that, they tell us what x is. So you take x out and replace it with what they say it is. And then we evaluate, is 6 plus 9 equal to 15? The answer is yes, it is. So we write 6 is a solution of x plus 9 equals 15. Because 6 makes that statement true. Let's check out B. You're going to think B is true just for a second, and then you're going to recognize it's not. Y over 4 is equal to 32. And then they tell us that y is equal to 8. So you think, yeah, 8, 4, 32, that makes sense. But if you actually critically think about it, if you take y out and put an 8 here, 8 over 4 means 8 divided by 4. 8 divided by 4 is 2, and 2 is not equal to 32. 8 is not a solution of the equation y over 4 equals 32. So I want you to be careful about going too fast on these. When you look at this 4 and this 8 and this 32, you think, yeah, that's going to work. 8 times 4 is 32. But this is not an 8 times 4 problem. It's an 8 divided by 4 problem. So you have to look critically before you make your determination. Question C reads, 8x, and that's going to be equal to 72. And then they tell us that x is equal to 9. So I'm going to take 9 out, and I'm going to replace it, or I'm going to take x out and replace it with 9. So I've got 8 right next to 9. 8 right next to 9 means 8 times 9. 8 times 9 is 72. 72 is 72. 9 is a solution. So notice that the 2 times we said it was a solution, it's when it was true. And the 1 time we said it was not a solution was when they gave us the numbers that looked right, but it didn't fit the correct operation. Okay, well that's all we're doing on page 297. That was just a preview. We're going to go ahead and let this video roll onto the next page, and we're going to turn the page, and we're going to do we're going to actually do the entire page 298 on the same video. So we are right now at the top of page 298. The Your Turn says, determine whether the given value is a solution of the equation. We're simply going to write yes or no on these, but we're going to figure it out first by solving. So we're going to go find that n is equal to 5, so we're going to take n out and replace it with 5. And is this statement true? 11 equals 5 plus 6. That is true, so we're going to write yes. We could write a whole sentence, yes, 5 is a solution, but we're just going to write yes. All right, number 2. Does it look like it's going to work? 18, 6, and 24? Yeah, I think it is. Nope, remember we have to look critically. Y is equal to 18, so we're going to take y out and replace it with 18. And now we have 18 minus 6, that's 12, and it says it's equal to 24. 12 is not equal to 24. This is not a solution. We're going to write no. Number 3 reads, x over 9 equals 4, where x is equal to 36. I'm going to take x out and replace it with 36. And I'm going to ask myself, what does 36 over 9 mean? It means divide. This is 36 divided by 9, which is 4, which makes this solution true. It makes X, it makes 36 the correct solution. The answer is yes. Number 4, 15 times t, where t needs to be equal to 6, is equal to 100. So the question here is 15 times 6 equal to 100? And we're going to find out. You can look on your multiplication chart. I happen to know that 15 times 6 is equal to 90. That makes this no, that is not a solution to that equation. All right, cool, good job. We're done with the top of page 298. Let's do some reading, and then there's some 4 more your turns at the bottom of the page. We are on the section that says writing equations to represent situations. You can represent some real-world situations with an equation. Making a model first can help you organize the information. Example 2. Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points. Write an equation to represent the situation. All right, so what do we know? We know a lot of things. We know that Mark scored 17 points. That's right here. We know that we add that to how much his teammates scored, because when you're on a basketball team, you get some points and your teammates get some points, and you add them all up. So that's 17 plus. We don't know how many points his teammates scored. We know they scored P points, so we're going to put P, so it's 17 plus P. And the total is going to be equal to the total, and we got to go over here to find that. It's 46 points. It says right here it was the home team. The home team on the scoreboard's right here, 46. So the equation is his 17 points plus his teammates' points is equal to the total number of points. Cool. It doesn't ask us to do anything else with that. It didn't ask us to solve. It only asks us to write. If you're like, well, what's P? We don't need to know that, because look at what the directions said. It said, write an equation to represent this situation. And writing equations is pretty much as hard as solving them. So let's just be happy with that for now. We'll be solving equations soon enough. Okay, your turn. Again, we're not solving any math problems here. We're writing math problems. Write an equation to represent each situation. We're basically going to take these word problems and we're going to turn them into math problems, and we're not going to solve them. Question 5 reads, Marilyn has a fish tank that contains 38 fish. There are 9 goldfish and F other fish. So what do we know is in this fish tank? We know it's a total of 38 fish. And since I know it's a total of 38 fish, I could put 38 at the end. Well, what's going to be at the beginning is the 9 goldfish, and that's like plus F other fish. I think the best answer for 5 would be 9 plus F equals 38. If it was important to you to write it as F plus 9 equals 38, in other words, you're changing the order of these, that's fine, because the associative property of addition states that you can change the order. I'm sorry, it's the commutative property of addition, states that you can change the order of an addition problem and it won't change the value. All right, we're on number 6. Juanita has 102 beads to make N necklaces. Each necklace will have 17 beads. So what's she going to do here? She's going to put 17 beads on each necklace, and she's going to make N necklaces. That means 17 times N, and she has a total of 102 necklaces. So this one is 17 times N is equal to 102. Please notice I don't put any X's or anything in between 17 and N. 17 times N is just written as 17N. All right, number 7. Craig is C years old. His 12-year-old sister Caitlin is 3 years younger than Craig. Younger means subtract. So he's C and she's younger. She's 3 years younger and she's 12. I bet we could figure out how old Craig is based on those clues. We don't need to. All right, number 8. Kim rents skates for H hours. The rental fee was $2 per hour. That's $2 for every hour she rents skates, and she paid a total of $8. That's 2 times H. All right, so let's go back and review how we know some of these terms. The word and here tells us it's going to be plus. This one's kind of tricky, actually. She has 102 beads to make N necklaces. Each necklace, well, it's probably this word right here, each. That means for each necklace, each of the N necklaces will have 17. That means 17 times. Younger means subtract. And number 8 is Kim rented skates for per hour right here tells us this multiply. It's going to be $2 per hour for H hours, so 2 times H. So I'm just trying to review with you what key words in the reading indicated what the operation was. I know these are a little bit tricky. Just be patient, and I'm sure you'll get better at it. Again, you can always watch the video a second time, or even better, you could ask me for extra help. Okay, good job. You're done with pages 297 and 298.